Alrighty, welcome to video number 2 for the constructive response section of, or constructive response problems of the LEAP practice test. Again, we're going to go through and use some of the techniques we learned in our boot camp to answer some of these questions. Alright, and since the last video took 40 minutes, let's just go ahead and jump right in. Hopefully session 2 will take less time. Alright, so number 24, they give you the problem, and we're going to skip that, just go on to part A and highlight our verbs so we know what we want. So blah, 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 blah. Describe this newly exposed two-dimensional cross-section. Now I'm highlighting that whole thing because we are describing the cross-section, but I want you to realize it's, you know, it's the cross-section that is created when we cut this. So we're going to cut off that block. So this newly exposed two-dimensional cross-section, and find its area. Show or explain your work. Okay. Alright, so now let's go back and read what the problem's about. Now that we know what we're doing, we're looking for a cross-section and looking for its area. Okay, so Daniel buys a block of clay for an art project. The block is shaped like a cube with edge lengths of 10 inches. Daniel decides to cut the block into 2 pieces. He places a wire across the diagonal of one face of the cube as shown in the figure. He then pulls the wire straight back to create 2 congruent chunks of clay. Alright, so I'm going to sketch what this would look like. You don't have to do this, but I highly recommend it. So let me get my little straight edge. And also, like on the LEAP test, you will be provided with a straight edge. Have your ID. If for some reason you don't like the straight edge, your ID makes a beautiful straight edge. Alright, so let's remember this is a 3D figure. I'm going to measure this. That's about 2 centimeters. Go down, boop. And that was about 2.5. Okay, I'm gonna kind of sketch the pieces we don't see, the edges on the other side. So we can kind of see this cube. And so when we cut through the diagonal, not only are we cutting from this diagonal to this diagonal, but we're also cutting from this diagonal to this diagonal, because that wire is going to go straight through. So it's going to cut it on this plane. And I'm going to highlight what we would see. So this is the cross section that we would see. And if that's hard to see, I'm going to do it should make a rectangle. So if we're struggling to see that, if you cut your cube in the diagonal, this is what the front would look like. Actually, that would be what the back would look like. So it would leave this rectangle open. And it should be a rectangle. That makes sense. Now we know that this is 10 inches. And we know that this is 10 inches. But the diagonal is what we need to figure out. So first off, describe the cross section. The cross section is a rectangle. Okay. Alright, so it's a rectangle. Now let's look at this. We know that this is 10 inches, this is 10 inches, but we don't know these long sides. If I look at the front of my cube, I know that the base is 10 inches and this is 10 inches. This would make a right triangle though. What would this side length be? You can do a few different things. You could do Pythagorean theorem, which if look, guys, if you know Pythagorean theorem, you know half of this leap test, okay? You can boil half of these problems down to Pythagorean theorem. Okay, you could also use special right triangles. If these two sides are congruent, then this is a 45, 45, 90 triangle. And there is a pattern to that. That would actually be 10 square root 2. Okay, let's say you didn't remember that though. You could do Pythagorean theorem, and that would be 10 squared plus 10 squared, and then you would take the square root. Well, 10 squared is 100, 10 squared is 100, that would be square root 200. Square root 200 in the calculator. Oh look, 10 square root 2, what? Change it to a decimal, 14.14. And let's see. And we want it to the nearest whole square inch. Now we're going to put 14.14 for now, but when we finish finding its area, we will we'll change it up. Okay, so area, this is a rectangle. So area is just length times width. Well, the length we have is 10 square root 2, or 14.14, but I'm going to do the math with 10 square root 2 because that's easier to put in the calculator, times the width is 10. 10 times 10 is 100, so that is 100 times the square root of 2. So 10 square root 2 times 10, okay, 100 square root 2. I don't know why that doesn't convert back, but okay, anyway, 100 square root 2 is 141.42. Now it does want to the nearest whole, so we'll round that to 141 inches squared. Okay, let's look at part B. Maybe, if I can get the pages apart. Okay, part B. Daniel wants to reshape the other chunk of clay to make a set of clay spheres. He wants each sphere to have a diameter of 4 inches. Find the maximum number of spheres that Daniel can make from the chunk of clay. Show or explain your work. Okay, so let's just remember, we are only using this chunk of clay. Okay? All of this is cut off. And let's also remember that it is 3D. So, you know, everything from here to here. We want all the bits that we have. So this block. All of this is gone. It's a triangular prism now. Isn't it? Yeah. Okay, so we could find the area of the volume of the triangular prism, or since that's half of the cube, we could find the cube and cut it in half. So the volume of the cube. Okay, and actually let's go through and do what we said. We want to find the maximum number of spheres. So we have, if we want the maximum number of spheres, we got to know how much clay we have and how much clay each sphere takes up. That is volume. So volume of cube, and then we're going to cut it in half. So cube is length times width times height. They are all 10, so that's 10 times 10 times 10, or 10 cubed. And 10 cubed is 1,000. You cut it in half. That is 500 inches cubed. Okay, so some people are going to be tempted to do 10 times 10 times 10 square root 2, which would give you actually way too much. Remember, also, your volume is area of base times height. So your base is a triangle, so it would be half of 10 times the height, which would be 10. Half of 10 is 5, times 10 is 50, times 10 is 500. So that works out too. You could have found the area of the triangular prism and gotten the same thing. Okay, so that's my volume of a cube. Now I need volume of a sphere. Okay, let's check our reference sheet. We do have volume of prisms, which a cube is a prism, area of the base times height. Volume of a sphere, 4/3 pi r cubed. So 4/3 times pi times my radius cubed. Now, let's see, our radius has a diameter of 4 inches. Well, if the diameter is 4, then the radius is 2, because we cut it in half. All right, so 2 cubed is 8. 8 times 4 is 32. So our volume is 32 pi over 3. We will make this a decimal later. In our calculator, it's so much easier to just use pi and use fraction, and the less rounding we have to do, the more accurate we are. Okay, so the number of spheres, if I have 500 inches of clay, and I want to see how many 32 pi divided by 3 inches I need, or I can do things with, we are going to divide these two things. So 500 divided by, in parentheses, 32 pi over 3. So we're going to stick this in the calculator. We're going to be very, very careful about it. You can do one of two things. You can stick the whole thing and use parentheses, or you can do 32 pi divided by 3 and then do 500 divided by the answer. So let's look at that. Let's do 32 pi divided by 3. And that's still the same fraction, so we're going to leave it as an answer. It doesn't matter. And then we're going to do 500 divided by the answer, and just plug in exactly what that answer would be. And that leaves me with 14.92. So how many spheres can I make? The maximum number of spheres that have a diameter of 4. We can make 14 spheres. And then a lot of people, Miss Gallant, but 9 rounds up. Well, if something, okay, if you have $500 and you can buy 14.92 of something with that $500, that $500 is not going to allow you to buy 15 of that. I mean, you can buy 14 of it and have some change left over, but you're not going to be able to buy a 15th item. Because, close almost only counts in horseshoes and hand grenades. It does not count in math. All right. Let's see. How are we doing on time? 15 minutes. Okay, that's not too bad. Let's move on to 25, and that'll be it for session 2. Number 25. Part A. The figure shows parallelogram ABCD with side length AE equaling 16. Let BE equal x squared minus 48. And let DE equal 2x. What are the lengths of BE and DE? Justify your answer. So again, work will justify your answer. One thing I do want to note, this is a parallelogram, which means the diagonals bisect each other, which means BE and DE are congruent. So BE is congruent to DE. We'll just put diagonals bisect each other. Diagonals of a parallelogram. Okay. So right now what we're doing, we are justifying and finding the lengths. Okay. So let's see. So these two are congruent, so we can set them equal to each other. X squared minus 48 equals 2x. Okay, so this is solving some quadratics. It's been a hot minute since we've done some quadratics, probably since algebra. There's a couple of different ways you can solve a quadratic. You can do some factoring, and if you don't remember anything about quadratics, you can use the quadratic formula every single time, and they give that to you on a reference sheet. I'm going to show you something easier. We're going to factor this. We always make sure that when we solve a quadratic, it's equal to 0. So x squared minus 2x minus 48 equals 0. At this point, you could use your quadratic formula. A would be 1. Here, let me stick this on this side so you can see. Your a value would be 1 because there's nothing in front of x squared. Your b value would be negative 2 because that's what's in front of the x. And your c value would be negative 48. You could plug this in and simplify it, and you'll get 2 answers. Remember, with a quadratic, you always have 2 roots, 2 answers. Something else you can do is you actually have access to Desmos. So let's see if I can pull Desmos up on my phone. Obviously, you cannot use it on your phone during the test. You have access to it through DRC. I could not think of it. All right, so a couple of things. I'm going to show you how to factor it and do it by hand, and then we'll come back to Desmos. So I'm going to set that to the side. So factoring, and you could also plug into the quadratic formula. Okay, so to factor this, we're going to split this into 2. Remember, we are wanting things that multiply to give me 48, but when I add or subtract them, I get 2. So factors of 48, we have 1 and 48. If I subtract those, I do not get 2. We have 2 and 24. If I subtract those, I get 22. We have 3 and 16. Subtract those, get 13. We have 4 and 12. Subtract those and get 8. 5 doesn't go into 48. 6 and 8. 6 minus 8 gives me negative 2. 6 times negative 8 gives me negative 48. So we're going to plug in x and x. This is negative, so you want a positive number and a negative number. So positive and negative. This is a negative number, so your larger number is negative. Your smaller number is positive. And these are equal to 0. So then I solve for x. X plus 6 equals 0. X minus 8 equals 0. All right, if I subtract 6, x is equal to negative 6. If I add 8, x is equal to 8. Now, if I plug this in, negative 6 would give me a negative diagonal, and distance can't be negative. That does not make sense. So we're going to close that out. We're going to plug 8 into 2x. 2 times 8 is 16. And let's double check this. 8 squared minus 48. 8 squared is 64 minus 48. And 64 minus 48 is 16. So what are the lengths of BD and DE? BE and DE are 16. They both equal 16. Okay, so let's say you have no idea how to factor and you don't remember that. If you use the quadratic formula and you plug in 1 for A, 1 for A, negative 2 for B, and negative 48 for C, and you just plug it into this formula that it gives you, you'll get that x is equal to 8. Plug it in to get your side lengths. If you don't remember that, we're going to change this 0 to y, and we're going to do y equals, we're going to graph y equals x squared minus 2x minus 48. And then we're going to look at where that crosses the x-axis, where my value is 0. So when y is 0, x is negative 6, and x is also 8. So those would be my two roots that we found. All right. So that's fun. It's been a minute since we've done quadratics. Anyway, and then you plug in your 6 and 8 and get, I'm sorry, you plug in 8. You're not going to plug in negative 6. But you're going to plug in 8 and get 16 for your side lengths. Excuse me, your diagonal lengths, segment lengths. All right, so part B, what conclusion can be made regarding the specific classification of a parallelogram? And then justify your answer. Okay, so let me find a separate little sheet of paper to kind of do the family tree of parallelograms. Okay, so if an object is a parallelogram, the diagonals bisect each other. Okay, all diagonals of a parallelogram bisect each other. Okay. If all the sides are congruent, then it is a rhombus. Now, if it's a rhombus, the diagonals are not necessarily congruent, but the side lengths are. And that's because the reason the diagonals might not be congruent is because your angles, these two angles and these two angles are congruent. These two and these two are congruent. But because you're bisecting different pairs of angles, this diagonal will be a little bit longer than this diagonal. So they'll bisect each other, but the diagonals won't necessarily be congruent. But the side lengths are all congruent. If I have a rectangle, then what happens is this diagonal, we form a right triangle. And then we form a right triangle here. So we have two right triangles made with the same side lengths, which means the diagonals are all congruent. Now, we can have parallelograms that are not a rhombus or not a rectangle. They're just random parallelograms. Now, if the side lengths are all equal, and we have four right angles, so that the diagonals are congruent. It's like a rhombus and a rectangle have a baby and they make a square. Okay, so going back to this. So this is not drawn to scale. That is very, very important, okay? 16 and 16, 16 and 16. The diagonals are congruent, which makes it not necessarily a rhombus because we don't know about the side lengths. It does make it a rectangle. Now, since we don't know about the side lengths, we cannot call it a square. The most we can say it is a rectangle. And what we're going to say is because BE and DE are congruent to AE, because this is 16, this is 16, this is 16, which is congruent. AE is going to definitely be congruent to CE. because diagonals bisect each other. Since BE and DE are congruent to AE and CE, the diagonals of the parallelogram are congruent. So parallelogram A, B, C, D must be a rectangle. So this is not drawn to scale. If it was drawn to scale, it would be a dead giveaway that it's a square or a rectangle. So they can't draw that to scale, or, you don't have to actually do any math. So remember, trust the numbers, not necessarily the picture. Okay. Let's see. That is it for session 2. Let's see. Okay, 25 minutes. That's not too terrible for 2 questions. All right. So I hope this was helpful, and go see, whenever you're ready, move on to video number 3. Have a great evening.